And then once again, for those who are joining, welcome, glad you're here. You get a lovely picture of Dr. Mike Killian to look at right now. My condolences. And so you go to in the team section, if you go to the week 2 channel, there is the code for this week and a slightly updated version of HSB data. There's just one additional column. It is not necessary, but you can use that and just some things that we'll be through. So again, it's up to folks whether they want to be kind of moving along with the code, watching it and replicating this later or otherwise. So one additional piece that I was thinking about after last week is if there's questions you have just broadly about the topic, it doesn't even have to be specifically about the code. It could be just about the topic we're walking through. Feel free to put that in the chat, and either myself or I'm sure the more knowledgeable people or the eager to answer people, sometimes those are not the same people, will probably post a response to help. So yeah, my little buddy is with me again, happily watching Mickey. So please excuse any. All right, Teddy, a little quieter. You can watch Mickey, but no yelling, buddy. So we're gonna get started. All right, welcome back. Glad you're here. So last week we kind of did a very brief overview of kind of what the functionality of R, and yours is watching Princess and the Frog. Love it. That's great. So we'll probably go in between Mickey Mouse Clubhouse, maybe Avatar: The Last Airbender because it's back on Netflix and it's the greatest show ever. Don't at me on that. So we kind of did an overview of our studio and kind of walked through what this environment looks like. Got into a little bit of functionality in terms of the way that R can be flexible, talked about reading in data, a little bit about installing packages. And so for the next 3 weeks, including today, we're going to be talking about data management. And so for those who are new this week, we're going to kind of do 3 major movements this summer to provide some overview and building blocks related to data management. And then in July, we're going to be moving into data analysis. And then August will be data visualizations. So for the next 3 weeks, we're going to be talking about tidyverse. And today is really going to be kind of looking at some of the foundational aspects of tidyverse. And we're going to do that in the context of, you know, when we're working within a data set, right? We're not talking about how to merge yet and all of those complexities. It's just when you've read in a data and there are things you want to do and some things you want to know, how can tidyverse help facilitate those kinds of things? And so whether it's being able to kind of filter out cases, be able to reduce a data set down to kind of just choose in a large data set a few select variables, we're going to cover that. We're going to talk about some kind of very basic summaries that you can do with tidyverse. And then I think probably some other things that I've already forgotten. So that's what we're going to cover today. Next week is when we will start with data merging, because that's the one that is the most hair-pulling activity, which is why Mike Killian looks the way he does. That was all from pulling out your hair, right, Mike? Yeah. You're on mute, so you can't say anything. Mike and I are friends, so it's okay. So to start, if you have not already, I would encourage you to install the tidyverse package. And we kind of did this a little bit last week, but just as a refresher, you could either run this code, you can highlight it and click run, and that will run that line of code. You can also just have the cursor next to the line you want to run and then hold the control button and hit enter. No, I don't want to do that. I don't want to upload anything. That's going to take time. So I'm just going to actually call it. So you can just type this line and enter it, run it, or you can go over here to the packages and you can click on install. You can click on a repository, start typing tidyverse, and then you can click that and click install, and then that will do it. So you can go ahead and do that. You can then access tidyverse. You can call the package here. And then if you haven't already, go ahead and find the directory where you want to work. And so for those who were not here last week, or even just as a refresher, you want to kind of keep your code and your data in the same directory, in the same folder. So for me, I'm keeping it in my Dropbox in a folder called Failing at R. And so you can just quickly type or copy the directory, and you can kind of drop it right into this code, which is saying set the working directory to this pathway. And you can see what happens when you copy and paste it is that it's with backslashes. And we need to change that to be forward slashes. And so you'll want to replace all the backslashes with forward slashes. Yes, there's someone's asking about help for Mac people. I already gave the healthy disclaimer last week. I know nothing about Macs, but there are super smart Mac people in this that might be able to quickly help you with that. Whoa, Teddy, you okay? Uh-oh. Oh, you're okay. Sorry. We had someone fall. Okay. All right. Here, let's see. All right. Okay. It's all right. I know. All right, here. Go downstairs and find Mama. I know. Sorry, I have to be back in 1 second. All right, come on. Yep. I know. Oh boy. The joys of being an acadad. So sometimes we have to put the academics aside and parent for a minute. All right, so once you've changed that from a backslash to a forward slash, you can set that working directory again by highlighting and hitting run, or just having the cursor next to the line, hitting control, holding control and hitting enter. All right, so go ahead, and once you've set your working directory, you can read in the data. I'm choosing to call the object that I'm creating, or kind of the data frame I'm creating. I'm going to call it HSB because the data set I'm reading in is HSB, so I'm just going to give it the same name. And what you can see is when I run that line of code, it read incorrectly because there were no warnings, there were no errors. And up here is where now that new data frame is stored. And so this is, again, telling me there's a certain number of observations, and there are 6 variables. And if I click on this little arrow, right, so this is some review from last week, I have a student ID indicator, a school ID indicator. There's a dichotomous variable that represents if the student is a minority or not, coded as 1 for yes, 0 is no. A dichotomous indicator for if the student is female or male, and then 2 continuous indicators, 1 for socioeconomic status and 1 for math achievement. This is great. Everyone's kind of putting some comments in there to help. That's wonderful. Thank you for doing that. So as a way to kind of introduce things related to data management, we talked a little bit last week about different ways we can actually view the data, right? Because when we're wanting to do data management, it almost starts with, well, what does it look like? And so if you're working within SPSS, you always have the data right in front of you. But then the limitation is you kind of have the code in a second window, or you're kind of doing the point and click. SAS is kind of the same way. You kind of have your code editor up top, you have the result of running the code up top. You have the code on the bottom, then the data sets are off to the side that come up in a smaller window. So in R, we can access data multiple ways. One is through the view command. Remember, R is case sensitive, so it's a capital V. So if I want to view the data, I can run that line of code, and it's going to open up the data set so I can see that pretty quickly. You can also sort it if you didn't know that with these little arrows. You can sort the data just by clicking that. All right, so it'll sort it from highest to lowest value. So that way, if you want to just get a quick sense of what's happening with the data, what it looks like, does it seem reasonable, you can use view. Another way is you could actually just run this line of code. And so the data set's called HSB. If you want to look at it, you can do that, but it's going to populate differently, right? So if we click on view, the data set pops up here that you can look at in a tab. If you run an HSB line, you can see that it's different, right? It actually populates in the console down here. And in order to view it, you kind of have to scroll all the way back up. So this can be limiting for a number of reasons. One, you don't have like a nice column view of it. You also can't see the entire data set. It gets truncated. And so there are ways that you can kind of quickly look at different aspects of the data. So if I did something I think it's head HSB, it's going to show the first, the first 6 entries. And so that's just showing the top of the data set. And if I wanted to look at the end, because when I did it up here, right, it's omitting 7,000 rows. If I wanted to know what's happening at the end of the data, I can do tail HSB, and then it's going to show the last 6 entries in the data set. So that's a way you can kind of quickly see what's happening. You can also just click over here in the environment. If we just click on that, it's basically running the view command that I had already typed. So those are different ways we can be able to observe the data. And then lastly, we kind of talked last week where we could create a new data matrix as a function of our current data. Right now, HSB is a data frame, right? It looks like just a regular data set. But for different types of analyses, we might want to do different things where we don't want like a data set. We want things in a type of matrix form. So here, I'm creating a matrix called WOOF, and I'm saying create a matrix called WOOF that makes HSB as a matrix. So it's saying create an object called WOOF that kind of changes HSB to be as matrix. And if I run that, you can see I don't have the little arrow to give the elements. It's just telling me the structure of it. So if I click on that, it will open it up and it looks like HSB in the view command, but it's structured as a matrix. So if I type WOOF, it's going to look a bit different. Right now, you actually have everything that's at a matrix level where it's giving a row, and then it's also going to give kind of a column block. And so you could then, if you wanted to select data through a matrix, you could actually define it using kind of matrix language. So if I said WOOF 2, 4, right, it's pulling out the second entry from the 4th row. Sorry, from the 4th column. So it's a row by column pull. So this says, WOOF 2, 4 is pull out from the 2nd row the fourth column value, which is 1, right? It's 1 for female. So that's why when I run this, it just gives a quick cell value for that particular entry. So another way that we want to be able to view data that's a little bit more beneficial for our purposes is by using tibbles. And so in tidyverse language, you can think of tibble as being like a table, tibble, table, table, tibble. So in tidyverse, we have tibbles. So if we wanted to take our HSB data and then start looking at it and viewing it as a tibble, you can do kind of like the as matrix, right? We're changing the nature of HSB as a data frame. This converts it to a matrix. We can do the same thing, but we can create it as a tibble. So we could say as tibble HSB, and now you can see it looks a little bit different, right? There's a little bit more aesthetics there. It's giving the first 10 rows. It automatically tells you the type of data that it is, right? So if I looked at what the structure, or if I just looked at the HSB data here, I get the values and I get the column headers, but I don't know what the structure of the data is. I don't know if it's character or string, character or numeric. I just have kind of cell contents and column headers. Viewing things as a tibble lets you to be able to see the header. It lets you see the kind of breadth and depth of the matrix. So for the person that's saying couldn't find the function as _tibble, you may want to see if you have both installed tidyverse and then use the library tidyverse. And so you want to make sure that when it's loaded, you should get something like this. And then when you do as _tibble, that should run. So that's one way to be able to look at your data as to go from a table to a tibble. You can also just do tibble HSB, and so it's a little bit of a different way to do that. So that would be if you have data that's already kind of fed in, you can just view it as a tibble by using as_tibble, and then it's going to have the entire matrix kind of viewed as a tibble. You could also create a matrix or create a data set and kind of create it as a tibble. So if you wanted to just do something simple, whether it's for class presentation purposes, or you want to simulate data, and so you already know the parameters and the specification of what those variables should look like, you can do something like this. So this is saying create a tibble where the first variable is called meow, and it just has 10 values that are sequenced from 1 to 10. I then want a second variable called woof, and that is something that I want to have a sequence that goes from 2 to 20 by increments of 2. So I can create a very simple tibble by running that, and you can see now I have a 10 by 2, 10 rows, 2 columns. I have a 10 by 2 matrix where meow has values of 1 to 10, and woof has values of 2 to 20 by 2. Yes, you can do that as well. I could do something like woof tibble, and I could create a new object that's called woof tibble that is creating a tibble with those 2 variables. And so then I can do that right there. I think there might be 1 or 2 people who are unmuted. If you could go ahead and mute, that would be helpful. So tibbles allow you to be able to view data in a little bit more of a useful fashion. So again, you can see what the variables are automatically. You can also see the variable types, and then you can see some interesting things about the values, right? And so negative values are in red, and positive values are in black. So that's also a useful mechanic for being able to view data. There's a little bit more aesthetics that are tied to tibbles versus then if I just, again, did HSB and I wanted to look at the data, it's going to spit everything out, but there's not an aesthetic to it. So tibble really helps with being able to kind of quickly see some different aesthetics related to the data. Tibbles are flexible the same way, like last week when we said, can you change a numeric variable to be character? Or could you go from character to numeric? So for example, in the HSB data, if I wanted my ID variable to be character, I could do something like, let's go with HSB ID HSB. I think this is, let's see what happens here. All right, so if I've done that, right, so now I've created kind of this new ID here. What I did was say create a new variable called ID in the HSB data set and make it a character version of the current student ID variable in the HSB data set, right? So for student ID, it's integer, running from 1 through 7185. But I created a new variable called ID, and that's now a character, which is why ID has quotes, right? So you can do that with your data frame. You can also do that with your tibble. So here I'm creating HSB1, which is a tibble version of HSB. It's the exact same as kind of what I did up here when I did as tibble or tibble HSB. I've just now created a new file that is specifically a tibble. So I can do the same thing of HSB1, create a new variable called ID in this tibble, and I want it to be a character version of, what was it, student ID. And then if I kind of call that data set, right? So I've got student ID as an integer, and now I have ID is a character. There's not quotes in it, but you can see there it's expressing this variable as a character. So there's a couple other quick things that are important to know. If you want to read in your data set, the way we read in the HSB data was by using read.csv. And so I'm going to call this just HSB table, and I'm going to read it as a CSV using the dot. You could also read it in directly as a tibble using an underscore. So if you use an underscore instead of a dot, then it's going to be a tibble. And so you can see that it's kind of like parsing some of the things there. But structurally, if I do the HSB table, right, it's printing it out like I would the original data that we read in, right? So HSB table and HSB look the exact same. And that's because I use the read.hsv or read.csv, sorry. If I read in a new data set, so I've got the same original file, but instead, if I do read_CSV, and then I call that data file, you can see that it automatically produces it as a tibble. So if you do that, then you don't need to do as tibble, and you don't need to do tibble of the data set. It's already being read in, so that way anything you start doing with it is kind of in this tibble format. And then you can also write out your data sets in the same way. If you use write.csv, it's using the properties of the data file that exists as a table. It's writing it out that way. And if you have the tibble, it's going to write it out that way as well. So you can use write.csv, or you could use write_CSV. So that's a very brief overview to just considerations for using the tibble function within tidyverse for reading in data, for manipulating some variables in terms of whether they're character or numeric, and what happens if you kind of write those data sets out. So now what I really want us to focus on for our time today is kind of the intro to data transformations. And to do that, this is me personally. I find these 5 to be the ones that I go to over and over again. They're probably the 5 more popular types of functions within tidyverse for looking at transformations. And so that's the FAMs. So it's filtering, arranging, mutating, selecting, and summarizing. So filtering, the filter command, is where you can choose observations based on a value. And so if you want to, in this data set, if we wanted to choose where female equals 1, we would use a filter command. Arranging is for reordering rows. And so if we want to look at sorting data, kind of look at ascending or descending, you can use the arrange command. There's some other things I think we'll talk about with that. Mutate is one that you'll probably use a lot. So when you want to create a new variable in your data set that's based on either existing variables or some other type of mathematical function, you can use the mutate command to be able to kind of create new variables. Select is picking variables based on their names. And I'll show it's really great. Select is very flexible, where if you don't remember what the name is, you can kind of start typing in different letters, and it will return variables that have kind of those letters. So it's actually really useful for if you don't know the exact name. If you're like me, sometimes with big data sets, you end up doing like variables that have lots of underscores with different parts to kind of keep things straight. So select is a really useful command for being able to do that. And then summarize is doing a lot of different types of summary and aggregates, whether it's means, median, standard deviations. We'll get into all the different things it does, but it's really kind of like getting some aggregated kind of data, whether it's doing things at an entire data set level. And so if we write in this entire data set as a tibble and did some summarize, we could get means for the whole sample. Or you can get aggregated means according to different group levels. And that's where this command is actually incredibly important. So the group by indicator, yeah, that's good. So I think summarize with an S, I don't remember what summarize with an R does, if that is specifically tidyverse, or if that's another, let's see. Yeah, so create one or more scalar variables, summarizing the variables of an existing tibble. Tibbles with groups will result in one row. So let's see. I mean, it sounds kind of the same. So I don't know the answer. And so yeah, I don't know. If someone knows, it'd be great if someone could put that response. Otherwise, as you type it, right, we talked about this before, you can kind of hit F1 and it's going to give you information over here. They have both spellings for UK and US. Okay, so it sounds like they might be identical. It's just whether you prefer a UK or a US spelling. So I'm going to go with the US. Is Hadley Wickham from the UK? And maybe that's why. Maybe, I don't know. Okay, so these are 5 main functions. But one of the things that's great about this is the group by statement. So this is kind of I view it as a moderator. where you can kind of use these things in conjunction. You can use group by in conjunction with a lot of these commands. So you can kind of like summarize with a group by. So that way, if you're grouping by, let's say, sex for female, so if you want to group your results by sex, then when you use the summarize command, it will give you, let's say, a mean by each of the groups in your group by statement. So that's a pretty useful function. So group bys, as you'll see in some of our code, it's pretty helpful for managing or transforming data. What's really nice is that by and large, each of these 5 main transformations in tidyverse, filter, arrange, mutate, select, and summarize, they kind of have the same form of expression. One is you state which command you want, right? And so if you want filter, you would say filter. You then kind of say the data set that you want, and then you say what you want to do, right? And so it's really let's say command data, and then what do you want? That's really just the format for all of these. And so if you want to filter, you do a filter HSB, and then if we wanted to subset the data on sex, we would say female equals 1. And so then what it's going to do, right? It's going to do that whole thing. It's spitting out all the observations for female equals 1. All right. I'm going to delete that. All right. So an example structure is a tibble. Kind of, we saw this a little bit, right? So here's a tibble. So if I do filter it, you can see here that the original data set, right, for the tibble is approximately 7,200 observations. And so if I want to look at something related to just females, and I run this command, and you can see the tibble that's produced, it's 3,795 rows with 6 columns, right? We've got these original 6 columns, but the data set is smaller. And you can see that when we look at female, right, it's all ones. We can do the flip of that. We could do female equals 0. And so in this case, we're going to get a response where it's all zeros. And so here it's 3,390. And so if we kind of add these two together, we would get to 7,185. So this is a very quick way to start kind of subsetting your data for different things you might want to do. And we can do that with continuous variables as well. So I can do a table where I want to say filter out, in this table, filter out where I'm only keeping cases where SES is greater than or equal to 0. And so now I'm getting a tibble returned where I can see that there's 3,619 observations in this data set where SES is greater than or equal to 0. All right, I see some people are having just some issues using an older version of R. So yeah, I would check up here for your version of R. If you go to Tools and Global Options, it's going to tell you what version of R you're working with. So I'm working with 3.5.3. You'll want to make sure R is a higher, around this level. Yeah, so if you want to just go back to the original data, to the original tibble, right now I actually haven't done anything to that original tibble, right? So even though here I'm saying filter out where female is equal to 1, it's actually not saving that. It's only producing a tibble for you to be able to observe. So that's a great question. When you start with this, if you're only using the command, it's only producing what you've told it to, right? We don't have anything to the left of filter. And so we haven't said create something new. We've just said produce a tibble that has observations where female equals to 1. So if we go back to the original tibble, you can see the data is intact. If you want to save your work as a new tibble, this is where you can kind of create a new object, right? So if we take this command and we want to store it in a new object or a new data set, you can run this. So we could actually say, female equals filter. And so one is you can see that we don't get the tibble populated here, right? Because we've actually said store this information right here into female. Don't put it down here. So if we go up to the environment, we can actually then view this, and you can see that everything is stored in a new data set. Now you can go ahead and call that object, right? We can say, produce this information, and because we did it as a tibble, it's also stored as a tibble. So that's a way that you can kind of create, not just filter it within the R environment, you can create and save it as a new object, and we can do the same thing with mail. We can create a data set called mail, or we can call it giraffe, or we can call it, you know, Aura. I don't know. I think Cora is a little bit cooler than Aang, but people might. You know, most of my nerd rabbit trails will kind of be, it'll either be like basketball, Airbender, Dragon Ball Z, or I don't know, maybe something related to superheroes, but that's you need failing at R 0.1. That is awesome. That's a great comment. Okay, so that if you want to save your work as a new tibble, you just put it in a stored object or like a data set. Now, if you wanted to simultaneously kind of do something like we had here, right? Filter the data, but you also want, and so you want to be able to see the result right away, but you also want that result stored. All you need to do is wrap that entire expression from like line 74, where you're creating a new data set, wrap it in its own parenthetical, right? So if you do an open paren before female, and I'm just calling it female 1 just to kind of show it. If you do an open paren at the beginning, so this is create a new object called female 1, and that's where I'm going to be storing all the females in the data set. And then I have a closed paren at the end. If I run that, you can see it both creates, shows the tibble and has saved it as a new object over here. And then I can do the exact same thing for males, right? It's creating now a new object called male 1, and it's also producing the results down here. Okay, a reminder, and this is what's nice, right? Sometimes R loves you. And so, and actually in this case, it's RStudio loves you. No, sorry. It's, oh my gosh, what is this even called? Tidyverse, Hadley, there we go. Hadley loves us, right? So female equals 1 must not be named. Do you need a double equal sign? I mean, it's kind of sarcastic because it's like obvi, but it's also like super nice. Like it's actually trying to help you to say, maybe you want to kind of add that. So just a reminder that if you're trying to set, if you're wanting to use an equals, you want to use a double equals. Otherwise, it's trying to evaluate an expression. It's trying to look at what it thinks you're saying is female equal to 1? And it's like, well, I don't know what to do with that because you haven't previously defined female. So it's trying to look at like a logical expression. So like if you were to say 2 + 2 = 4, it may come back as true because it's trying to say, does 2 + 2 = 4? But if you, and if you said 2 + 2 = 5 in R, it would come back as false. Let's just see if I'm right on that. 2 + 2 = 5. Right, so it's, well, so I did a lot of things wrong there. Oh, it's because I've tried to do it. I've tried to create an object called 2 + 2. Let's do it. There we go. So this is saying false, right? Because 2 + 2 does not equal 5, so it's returning it as false. If I do 2 + 2 = 5 this way, it's trying to say it thinks I'm trying to create a new data set called 2 + 2. Like here we're creating male, female. Here we're creating male. It thinks I'm wanting to create 2 + 2. And it's like, no, fam, you can't do that. You need a double equal sign in order to do that. All right, so there's lots of different arguments that you can use inside of a filter, which we want to do that a lot with our data, right? Sometimes we want a subset on multiple things. So you can use the ampersand. That means and. I think that the pipe. And I don't want to use pipe because we're going to be using something else that tends to be called a pipe in tidyverse, but well, I'm going to call it stick person. I don't know. I'm going to call it stick. Is that okay if I call it stick? Unless a real programmer here has a different phrasing for it that is both technically correct and doesn't conflate with the tidyverse pipe, I am totally open to that because I don't know. So ampersand means and, this means or. double equals is equals, and then an exclamation point means not. And so you could do like exclamation equals means not equal to. So if we want to be able to say choose, choose this or don't choose this, you can use these functions to say choose this and this. You could use this to kind of say or, this to do equals, and this to say don't, not equals. You would use the exclamation point. So here's a couple examples of and. So again, not creating a data set, but just filtering. This filters on female equaling 1 and SES being greater than 0. And so if I wanted to be able to create a tibble that is based on being female and having SES greater than 0, then it will produce that there. You can do multiples of those, right? So I can say if you're female and your SES is greater than 0 and your math achievement is less than 5, right? So I want to create a tibble based on those conditionals. So you can see that the sample size is getting smaller and smaller the more restrictive I'm being with the data. So what starts with 7,000 gets down to 172 when I restrict it based on sex, SES, and math achievements. Not sure why I was doing that. I don't spot any differences there. We'll delete that. So those are some examples of ands. Here's some ors. So I might be interested in looking at including individuals that are either female or their SES is greater than 0. So I can run that, and you can see that here are 2 people that were included because they're female, even though their SES is not greater than 0, right? Their SES is less than 0, but they met the first conditional. They are female. Whereas this individual is not female, but their SES is greater than 0. So this conditional allows you to include a broader array of individuals. So it's going to allow you to keep either those who are female or those who have SES greater than 0. And then I can do this, another example of that where I can say if you're male or your math achievement is less than 0, right? So in this case, they're male, and in this case, they are female, but their math achievement is less than 0. And then here's an example of a not equal. So I use this a lot for data sets where I'm wanting to remove different aggregates. So like for multi-level models, sometimes if you've got a large data set when you're doing kind of random effects mixed models, you don't have a sufficient sample size to be able to kind of like estimate random effects if you've got like a one-to-one relation between you've got like one student in one school. Including that school in a small samples of schools is unwise because you're not getting the right estimate of your random effects because your student ID is conflated with your school ID. That's a whole other issue, and it depends on kind of the number of upper level units and all that kind of stuff. But if you wanted to quickly remove a couple of your aggregates, you can use something like this, right? It's yeah, that's a good question, Florina. I don't know the answer. So Florina is saying if you're doing not equals, why is it's a single equals and not a double equals? So let me do this one because let's see what happens. So if I wanted to filter out those first set of schools, you can see that I did 1224 because that's at the top of the data. You can see that now that school is gone. So this is saying select all schools that are not equal to this. So I'll go back to again, like here's the original tibble. So I don't even know what happened. I've never tried that before. Yeah, so there's your answer. I don't know programming wise why, but all I know is that you can't. So you could ask Hadley. Hadley is accessible on Twitter, and he might be able to answer that for you. All right, so so here's again some combinations that are including not equals and equals. So this would be filtering out within the tibble. Choose individuals that are female that are not in this school. Right, so now I have a data set of females, and I've also removed school 1224. This would be kind of choose schools that are not 1224 and those who are female together, or their SES is less than 0. So now you're getting into like all these crazy conditionals where it's like the school is not equal to this and they're female, or their SES is less than 0. So the reason why these individuals are in this tibble is because even though they're female and they're in this school, their SES is less than 0. So they still would be included because I included this or. And if you try to do kind of this parenthetical, it does the same thing, right? It's not blocking it, it's kind of reading it all together. And then here is a last example. So if I chose, if math achievement is less than 10 and you're female, or your SES is greater than 2, then here's why you're included. So here's an individual who's included because their math achievement was less than 10 and they're female. Is there anyone who had an SES greater than 2 on this one? No, but they exist in the data. So those are just some examples of ways that you can use filter to both include individuals, exclude individuals, and then you can again wrap that into a new data set. So if I wanted to be able to take this tibble and create something, right, I can create a data set called APA, and that is kind of like filtering out all of these conditions. And you can see it's right there. So there's 1,492 cases that kind of meet this criteria. All right, so that's a little bit about filter. For arrange, okay, so this is sorting the data, right? So here's, I kind of forgot stuff. So here's the way it was, the data were read in, right? It's being sorted by student ID. So if I do arrange the tibble according to math achievement, it's sorting those cases in an ascending order. And again, I can go back to the tibble and the original data is still preserved. I haven't fundamentally changed the original data set. So I can do this for any of the data. I can do it based on SES. I can do it based on school ID. But then if I want to look at it descending, you can just kind of wrap any of these variables in with this second command of just do descending open paren variable descending. So if I want to, you know, again, in the main data set, the school ID is more or less ascending. If I want to look at schools in a descending order, you can just run that. And now you can see we've got school 9586 is shown at the top, and then all the way at the bottom would be 1224. So then you can also sort by multiple variables, right? So here I want to sort it by school in descending order, and then I want to sort it by math achievement. So it's first going to give us the last school, but then within the school, it's going to sort it by math achievement. So every single school will be sorted in a block manner, right? And so that would be the same as like an SPSS and SAS, is that, and probably Stata, is that it sorts according to the order. So it's first sorting on school ID, then it's sorting on math, and then you can add the other variables here. So that's arranging data. Oh, and then what did I just do? All right, I didn't do anything. It's not. There we go. So if I wanted to be able to have a new data set that was arranged that particular way, I can just kind of create this data set. You know, it's for show, and then it's sorted. It's sorted descending by school ID, and then ascending by math achievement. And then if I open this up, oops, that's female, not for show. There we go. So there's school ID, and it's sorting by achievement. If I scroll down a little bit, let's see if I can get to the next school. Right, here's the next school, and then it's also by achievement. All right. All right, so next is mutate. So mutate is kind of creating the new variables, or kind of like, yeah, it's creating new variables, manipulating some things based on the values that are in the current data set. So again, here's the base tibble. So let's say we wanted to create a variable in the data set that was just showing kind of like the individual deflections from the mean, right? If we wanted to be able to just know how far students from the mean the sample, one way to do that is we can first use the mean function. So we can just say mean, and then I'm specifying the data, and that's the original data. I'll just go like that for funds. And so I'm saying give the mean of math achievement in HSB Tibble. And so the mean of the data set is 12.74785. So I could do mutate, right? And again, it follows the same logic as the other ones we discussed. It's the command, the data set, and then what you want to do. And so in this case, it's saying mutate, or in this case, kind of create a new variable in HSB Tibble, and I want it to be a new variable called deviation. And I want deviation to be the math achievement minus the mean that we found from this previous command. So if I run that, you can see now there's a new column, right? So the new column is deviation, and that reflects the deviation of the individual's value from the mean. And so if you take this person, right, 5.88, and we subtract 12.74, you're going to get minus 6.87. And we could do the same thing here. Actually, no, that's for the next thing. So if you wanted to just simply create a new variable, that is one way to do it. You can. Sorry for these x's. These x's shouldn't be coming up because everything here is intact. It just started with this. I'm just gonna see what happened. That was the start of all of this mess. I'm gonna ignore it for now. But hopefully you are not receiving those errors. You know, you can see that it's an issue on this side because nothing is running incorrectly. So we can create a variable called deviation, and so now we're getting individual student deviations from the mean. So we could see that this student is performing below the mean by 6.87 points. This student is 7.6 points above the mean. And if we were to get the standard deviation, which is using kind of this same format as line 125, but it's doing SD, we could actually not only get a standard deviation, but we can create a z-score. And what's great about mutate is that it will let you create a new variable from a new variable that's in your current statement. So again, going back to this, if we're going back to Tibble, notice that deviation isn't in here because I didn't create a new data set. So if we were to kind of start from scratch, this is saying mutate, in this case, create some new variables in HSB Tibble, and then first do deviation, where deviation expresses the difference between a student's math achievement and the mean. And then I want to create a z-score, which is taking that deviation and dividing by the standard deviation, right? So the deviation doesn't exist at the data. Z-score is being developed or created as a function of this. So you can actually create new variables. You can have multiple expressions within one mutate statement. So it's first do this, then it's do this. But this line is being created after it's reading this line. So if I run that, you can see not only do I get deviation, I also get z-score. So the raw deviation is almost 7 points, and the standard deviation is -1. And that makes sense, right? Because the individual child's deviation is -6.87, and the standard deviation is 6.878. So this child's actual difference between their math achievement and the mean math achievement is 1 standard deviation below the mean. And we see that right there. So so that's a way you can use mutate. Just for as an FYI, if you wanted to just keep deviation and z-score, so you wanted to kind of create new variables and you only want to see the new variables in your window here, you can use transmute instead of mutate. So if I do transmute and I say the data set and I say the scores and I run that, you can see this only records the deviation and the z-score. I'm sure there's reasons for that. I would never do that, but that's me. Well, I don't want to say ever. I would never do that. I don't know how often I would actually use that because I tend to want my results tied to my individuals. And then same as before, we can wrap everything into a data set. And so I can create a new data set. It's for show. And now it has deviation and z-score. So that's mutate. So we've covered, what have we covered? How to filter data, how to sort data, how to create new variables. So now let's talk about select. So select is when we can start creating maybe subset data files based on the variables that we want. So if you work with a lot of data and you just want a smaller data set to work from, again, we'll start from HSB Tibble. And so what this is doing is saying select from HSB Tibble and just choose the student ID and math achievement. And what you'll just get are those 2 columns. You can do it without the quotation marks, or you can do it with the quotation marks. Either way, it's going to bring it back. I for tidyverse, I don't include the quotation marks, but that's just me. You could also, I don't know why people would do this, but I know there are some people that kind of geek out on this. You know, instead of saying student ID and math achievement, you can actually just reference the column number, right? So student ID is the first column, math achievement is the sixth column. And so I could say select from HSB Tibble columns 1 and 6, and it produces the same thing as if I put it in quotes or I don't put it in quotes. So here's what's really cool with select that I really like. We're close to end, but I'm going to keep going. And then if people need to drop off at 2, actually 2:05, because I forgot I have a call at 2. We'll pick up next week. Obviously, I'm used to lecturing for like 3 hours. So kind of trying to fit everything in 1 hour, as you can tell, is challenging. So we'll get to where we need to get, and then we'll pick things up next week where we need to. All right, so with select, this is where I was telling at the beginning. If you don't remember what the data name is, so there are ways to be able to like quickly look at the variable name. So if you do, I'm typing down here, but actually let me put it up here. If you use this dput names and then you put the data set, what this is saying is put the names of the data set in the console window. And what that's going to do is you can see it's producing kind of a vector of all of the data, the variables in your data set. And that works just fine when you have a few number of data sets. But for those who are doing kind of like big data or moderate data, where maybe you have 150 variables, when you use a dput, it's gonna kind of overload, or I mean, it's gonna load up your console pretty quickly, and then you got to kind of search. Instead, what you could do is, if you're like, I know that the variable that I want starts with an S, you can do select HSB Tibble starts with S, and it's going to say, here are the variables. Here is a tibble that shows you the variables in your data set that starts with an S. Again, it's not being stored in a data. This is just creating a tibble that you can be able to see the result of what you ran. If you said, well, what's the tibble that what's a variable that starts with the letter M? You can do that too, and it's going to return minority and math achievements. If it starts with MIN, you know it's going to return minority. So you can do things with starts with. If you kind of know, I know it starts with this, you can do it as ends with. So if you know that, again, the way that I do some of my variable coding, especially with a lot of multi-level models, I have different types of IDs. I have child ID, class ID, teacher ID, tutor ID, school ID, district ID. So if I know that I need an ID variable, but I don't know exactly how it's labeled because it might have 7 underscores in it or numbers or whatever else, I can say, well, I know it ends with ID. So return everything with an ID. So in this case, it's returning student ID and school ID. Or maybe I have lots of achievement measures. Maybe I know I have reading achievement, math achievement, writing achievement, and I know that it ends with ACH. I can do that. Or maybe I just know that it ends in an S, right? Like, so tidyverse is super flexible for being able to just choose the variables that you want based on those kinds of names, which is great. And then you can just, or you can use contains. So it doesn't have to be starts with or ends with. It could just be contains. Does it contain the letter A? So female and math achievement both contain the letter A, so it's selecting those variables. If it contains ID, in this case, containing ID is the same as ending ID. So that's why those are identical. But if id is in the middle of I'm trying to think. Well, there's letter word. So some people have like letter word identification developmental scale scores. And so it might look like LWIDDSS. It would return that because it has ID in the middle of it. So if it contains it, if it starts with it, if it ends with it, select is super flexible. And then again, when you find the variables that you want, you could use something like starts with S, and then you say, oh yeah, I wanted school ID and SES. Then you can go back up here and be able to say, I want school ID and SES, and I want math achievement. And so there you go. And if you want to then wrap it in a data set, you can kind of do ang is now a data set that has those 3 variables in it. Okay. We've got 5 minutes left. I want to save summarize. I want to save summarize for next time because actually, you know what? Let's start with summarize. because I think we can get through this block of common summaries, and then we'll pick up. And if you want to on your own time, kind of start looking at these group bys. What we'll do next time is integrate like the filter and arrange and all of those kind of things. So I would say if you want homework, would be kind of do everything from line 190, which is looking at kind of group by and summarize on your own time for learning. We'll revisit that next week and then start getting into some data merges, and I'll also be trying to careful to maybe not write 271 lines of code for 1 hour of work together. So, you know, I'm failing at instructing maybe as we're all failing at learning. So summarize again follows the exact same pattern, and then it's an S or a Z, whatever you prefer. It's the command, it's the data set, and then it's what you want to do. So these are some pretty common types of summaries. So let me just do this very basic one here. So I could ask for a summary of math achievement. And what you need to do for this is you can kind of create the variable of what you want your summary to be called, and then what you want that summary to be. So what this is saying is summarize in the HSB Tibble, create a mean of math achievement and call it mean underscore math atch, right? And what this is doing is saying remove missing values. So na.rm equals true means remove all of your NAs from the data set before calculating the mean. If you have missing data and you don't have this, then it probably won't run. You have to treat your missing data before using some of these summary statistics. So you could either pre-impute your data or otherwise, but it would just be like an SPSS, or SAS, you're only going to get means of values that you have. In this way, one of the ways you have to treat it is by acknowledging that you have missing values. So this is saying compute a mean just based on the data that you have. So if I run this, right, I'm getting a summary of math achievement. It's being called mean here, and it's 12.7. That's the same as you know, what we get right there. So summarize, if you want to do something very quickly, tidyverse, maybe it's not the greatest for just getting a quick summary. Like this is a lot of code when I can get the exact same thing right here. But the benefit is that you can get a lot of really great things integrated, both summarized and then, as we'll talk about next week, grouped by pretty quickly in ways that kind of like base R won't let you do. So some of the flexible things that R will do is give you summaries of locations. So you can get the mean of math achievement, like we just did. We can get the median of math achievement. So you can see that this format is the exact same, right? It's what you want, and then from where. And so mean math achievement, get the mean of it, get the median of it. You could do measures of spread. So if you want the standard deviation or the interquartile range, you can use that. Again, the structure is the exact same. You're just changing what it is you want and what you want to call it. You can get measures of rank. So you can get the minimum value in the data. With using min, you can get the maximum value of the data. You can get kind of like a percentile. You have to use the quantile. Don't think of this as like quantile regression. I mean, it kind of is, but it's more in the unconditional sense. It's closer to the percentile in this case. So this would be saying, find the value in the data set that's associated with the 25th percentile of the data. So you can get minimums, maximums, you can get kind of percentiles. You can ask for the first value, the last value, and the nth value in your data. So this would be saying, what's the 5th value in the data? So if I was to run this entire big block, I'm going to get something like this, right? And the problem is that some of these things want you to acknowledge what you do with missing data. Others don't want you to do that. So I think minimally, it's the measures of position don't want a missing data issue. So it's not going to be just a warning. It's going to be an error. So let me see if it's just those. All right, it's just those. So when you're looking at measures of position, you don't want to have that missing. You're going to want to delete those missing variable. You know, and so then you can see we get the mean, we get the median, we get the standard deviation, the interquartile range, the minimum value, the maximum value, the percentile rank. You can see here there's more values, right? It's saying that what about first, last, and math? And to do that, this is where, and we'll kind of end here, is if we put this in an object, then, and we go to set emoji, then we can actually get all the values, right? So I've now stored everything because it wouldn't print out here because there were three more variables. You'll want to put that in an object. That's a quick way to then be able to get everything else. So that is a very quick overview to some things related to tidy. I would encourage you to practice, kind of go through these things, use your own data. If you're feeling brave, I've annotated some things here about like starting to group things together. We'll walk through that next week together. So if you're just like, what is going on here? Don't worry about it. We're going to walk through it next week. I'm so glad we could do this again. I hope this was helpful. And if you have recommendations for how this could be done better, please let me know. I teach in all of my classes. I think it's important to have intellectual humility. We don't all know everything, and that kind of begins with me. So if you have thoughts on ways things could move forward, please let me know. Otherwise, looking forward to seeing everyone next week.